waters of the Yangtze River in China rises the biggest concrete structure on the planet. The Three Gorges Dam is over 2 kilometers long and 60 stories tall. It has taken 40,000 workers over 17 years to build. When it fully comes online, this one dam will produce over 20,000 megawatts of power, twice as much as all the nuclear power stations in Britain put together. It is the pinnacle of dam engineering. The Three Gorges Dam owes its success to 5 landmark dams. At the heart of each lies a major technological innovation that allowed engineers to build ever bigger dams. One by one, traveling up the scale, we'll reveal the incredible stories behind these structures. And the inventions that allowed them to produce ever more power. 6 ingenious leaps forward, from big to bigger, into the world's biggest. China is one of the fastest growing economies on Earth. To fuel the need of its ever-accelerating industry, the nation needs more power. Much of this will be provided by an enormous dam spanning the mighty Yangtze River in central China, called the Three Gorges Dam. Our cameras have been granted privileged access to capture this amazing feat of engineering in its full glory. Before they could start building the Three Gorges Dam, the Chinese first had to divert the Yangtze River, which is almost 2 kilometers wide, and move over 1 million people from the area about to be flooded.
Three Gorges Dam is the biggest hydroelectric project in the world. This dam used 28 million cubic meters of concrete. Maybe one way to look at it is to say it's a solid pipe of concrete, 1 meter diameter, right around the world. It's a lot of concrete.
But the Chinese authorities think it's worth the effort, as the Three Gorges Dam will provide clean and cheap electric power to millions of people. To understand how the Three Gorges Dam can produce so much power, we need to travel back in time to 19th century Britain and a modest stream in Northumberland, the power behind the world's first hydroelectric dam. In the 1800s, while Britain is at the heart of the Industrial Revolution, this house is the last word in modern living. It belongs to Lord Armstrong, an entrepreneur and obsessive inventor. He has fitted his house with state-of-the-art technology, including central heating and mechanical devices that drive elevators, laundry machines, and roasting spits. But there is one place in the house where modern technology is sadly lacking, as historian Anthony Burton explains.
This was Armstrong's real pride and joy. The picture gallery full of wonderful Victorian paintings. Bit gloomy even in daylight, but what he really wanted to do was to bring his guests here in the evening, but by the flicker of candlelight, nothing really worked.
What Armstrong needs are electric lights and a way to power them.
How do you generate electricity? Well, that's something that was known for 50 years because Michael Faraday had given the secret. You move a magnet in relation to a coil of wire. I've got a little setup here to show how it might work. Now, here we are. Here we've got two magnets on the end of this disc, and right here is a coil of wire. Now, if I make this spin in relation to that, we should make electricity. And yes, we're getting a reading on the ammeter. We are definitely making electricity.
Every time the magnets on the disc move past the coil, they generate a tiny electric pulse in the copper wire.
To make a lot of electricity, you need much bigger kit, and this is what Armstrong bought, the Thomson Vortex turbine, a grand piece of equipment.
The Thomson turbine needs a huge volume of fast-flowing water to drive the rotor. All Lord Armstrong has available is a tiny stream trickling through his estate.
What he needed was this, a lot of water. And how does he get this out of a small stream? He built a dam.
Armstrong builds an earth wall nearly 10 meters high, which turns his stream into a deep lake. This mass of water pushing down increases the pressure at lower depth. Armstrong channels this high-pressure water down through a pipe to the bottom of his dam. Here he injects it into a Thomson turbine, where the torrent spins the rotor. This in turn rotates a shaft linked to a generator that produces 4,000 watts of electricity. For Armstrong, this is only the first step to enlightenment. Now he needs to get the electricity from the turbine house at the bottom of his dam all the way to his picture gallery over a kilometer away. Armstrong connects 2 strands of thick copper wire to the generator to carry the electricity up to his mansion. All in all, he uses 5 tons of copper to power a single light bulb. But he has created a world first. A house lit by the power of water. On the other side of the planet in central China, the Three Gorges Dam takes Lord Armstrong's concept to the extreme. British engineer Robin Charlwood has been working on the dam since 2003 and is still impressed by its scale.
We're in one of the 3 very large powerhouses of the Three Gorges project. In this 700-meter-long room here, you can see 14 of the large turbine generators. Then beyond this one, a kilometer away is the second powerhouse, and then beyond that one is yet another powerhouse, which will be underground in the rock on the far side of the river. Each one of these generators cost about $50 million, to give you an idea of the scale of this project.
Debden Dam had 1 generator. Three Gorges has 32. Together they produce 5 million times more power than Debden. To To drive them, the Chinese have harnessed the power of the mighty Yangtze River. In the reservoir behind the dam, the river now rises up to 60 stories above the riverbed. The water is channeled down gigantic concrete tubes towards the generators. Here, the torrent of water hits the turbines and makes them spin. This motion is in turn transferred to the rotor of the generator. This is fitted with massive magnets, which move past copper coils in the casing to generate electricity. Just one of these machines makes as much electricity as a small nuclear power plant. All 32 generators together produce enough power for 60 million Chinese.
This project is setting a new benchmark in the international hydroelectric industry. It's almost twice the size of the next largest project, Itaipu in Brazil. And of course, it's only the first of a whole series of megadams that are under construction here in China.